Welcome to the ICT course. We are going to learn from the ICT Cambridge book. This is the book that we will learn from. Chapter 3 Storage Devices, Lesson Part Solid State Backing Storage and Flash Memory Cards. So, we will be covering the following titles: Solid State Backing Storage and Flash Memory Cards, page 31. Let's start. Solid State Storage. So let's look at three examples of the solid state storage. Number one is the magnetic tape. Number two is the flash memory. And number three is the hard disk drive. All of these are examples of a solid state storage. We can use these three in order to read data off of them. We can also write data on them, and finally we can erase data from them. Now let's see this question. How does the solid state storage work? First of all, here we have the control gate. This is the control gate. And below the control gate, we have the metal oxide, which is nanomaterial. Below the metal oxide, we have the floating gate where the material can float. The floating gate is also a conductor. That means electricity can pass through it. Then we have another layer of the metal oxide under the floating gate. Then we have below it the source and the drain. And all of these are connected to an electric circuit. So the figure that we are looking at now is inside the USB, which is a solid state storage. So how does it work inside the USB? So if we give the electric circuit a low voltage, then the voltage will travel like this. Look at the red arrows. They will travel to the source and then go to the drain. And here we will have current flows, and these are called electrons. So the electrons are electricity and they have the symbol E. And here in the current flows, we will have electrons like this. And here the bit value will be 0, and this is the binary language of the computer. Now let's see what will happen if we give it a high voltage. Then the electrons will be in the floating gate. So the electrons will be here, and we will not have the current flows that are below, so there will be no connection between the source and the drain. And the bit value here will be 1. When this is happening, the USB is reading the data. Now let's look at this case here where the source has an electron. If we give this a high positive voltage, like this, then the electron will move to the floating gate. And when this happens, then we are writing data. Now let's see the features of the floating gate. Number one, electrically isolated. That means it is an isolated section of the circuit. Number two, store data for a long time. And finally, can work without power supply.